Okay. Oh, that's now one. That's how life is. If you come back, yes, you say they have been started. Hi guys, can you guys can you see me guys? I don't know. Please, can you just type something? Let me know if you are following through. Can you see anything, please?
Someone said that.
Where? Oh, okay, okay. All right. Thanks for joining. Can you type your name? Okay, who is this? Okay, Salam. Okay, that is the guy from I think Morocco. I sent it to that group. So we are starting right away. This is 4:07. Let's say by 4 a minute more. Let's try to wait for some people. Instead of how to type here.
I can see you.
So for me, you are supposed to type here. Type on the screen. Sorry, on YouTube. What did he type? So we are trying to wait for other people. So yeah, fine. So I think we can. We are trying to wait for other people. So so I think we can. Let's start. I have to stop this one. It won't work because of the thing. This one. Okay, let's start the class quickly. Firstly, I want to welcome you to this amazing time. This is a special class, and trust me, your experience today is going to be something unforgettable that you can not really forget about it in a long time. Because what we are going to be looking at today is something very, very special and unique. Okay, let's look at this. So I want to believe you can see my board. So let me write mathematics. And under this, we want to look at um, inequalities. Inequalities. So I'm going to be starting with something very easy. We have some inequalities in mathematics. Basically, we have about 4 of them. Firstly, we have this sign. This is less than This means we are talking about numbers that are less than something. Then this one is greater than. In your primary school, I believe you guys used to use your left hand as your less than, this one as your greater than. All right. Anyhow you go about it, it's same. Then we have less than or equal to. This one means two things: less than or equal to, and of course we have this to be greater than or equal to it. Now I'm going to start with this. Let's assume I have x less than 3. Let's assume these are real numbers, or let me call it set of integers. Okay, integers are numbers, are whole numbers, either positive or negative. Okay, so when I say integers, just know that they are numbers. So now we are looking at x to be less than 3. It means that I need the values of, I need those numbers that are less than 3. That is, it must not be up to this 3. So that means those numbers can be 2, they can be 1, they can be 0, they can be the other side, negative. That is -1, they can be -2, -3. Since I don't have a boundary, I mean where I will stop, it keeps going on the way to infinity. But what type of infinity? That is negative infinity. So if I want to bring this into a closed set, like a bracket, now in mathematics we have two kinds of brackets. We have this bracket, also we have this bracket. This one is called a closed bracket. This one is called an opened bracket. So if I write in a bracket, let's say I have 3 and 2, that means that the numbers here does not really end here. Sorry, don't let me say 3 and 2, let's say infinity. No, let me say -3 and let's say 10. It means that the numbers here does not really end here. Okay, because it's open, it can exceed 3, and this one too can go beyond 10. But if I put this guy under this, it means that it must not be more than 3 and also be more than 10. But that's not where I'm going to for today's class. Let me just leave that. Now what I want you to know is this, is the meaning of this: x less than 3. It means that those numbers that are less than 3, that is 2, 1, 0, -1, -2, -3, -4, -5. Now these 3 dots, we call it ellipses or suspension points. It indicates continuity. Now these numbers is going to towards negative infinity. Okay, so if I, now that's why I cannot just stop here. So the right, if I want to put this into a bracket, I'm okay, I'm going to write, look at it, I'm going to write something. Okay, just let me stop here at the beginning. I don't want to stress you guys. Now what if I'm talking about numbers that are greater than, let's say, 5? Look at this is less than. Now this number is greater than 5. Those numbers that are greater than 5, of course 5 will not be included. That means the number can start from 6. Okay, so I can have 6, I can have 7, I can have 8, 9, 10, okay, 11, all the way to positive infinity is going to, because I don't know where to stop. If you stop, look, if you just write 6, 7, 8, 9, and 10, then you are tired. If you stop here, you are wrong. If you didn't put this suspension point, you are wrong. You have to include this, telling me that okay, these are numbers that are more or greater than 5. Now let's come back to these two other inequalities. If I ask you that x less than or equals to 3 now, okay, x less than or equals to 3. Now, these two inequalities, they have two options. This one means less than, or if it's not less than, it can also be equal to this number. So x is less than or equal to 3. Equal means it's up to it. It's the same thing. All right. So now if I'm talking about x is less than or equal to 3, That means 3 must be inclusive. 3 is there. That is, if x is not less than 3, it will be up to it. It will be equal. That is, it will be the same thing. That is, x can be 3 as well. So if I'm writing these values, okay, I'm going to involve 3. So that means 3 is inclusive here. Then don't forget, x can be less or equal to it. It's not saying that x is greater than it. It's still less, or it can be up to it. So that means that I have x to be less than 3 or up to 3. That is, 3 can be inclusive. And then going downward, that is, it's now less than 3. 1 till this guy. So we have minus 1, minus 2 towards negative infinity. That's why I represent it with my 3 dots, the suspension point. Now, if I want to say x is greater than or equals to 5, now the question says x is greater than or equal to 5. That means 5 is inclusive. Okay, now that 5 is there in the numbers because it's greater, not only greater, now it is also up to the 5. That means we have 5, okay, then we have 6, 7, 8, 9, 10. Then I don't know where I'm stopping because it's still greater than 5. So I'm going to represent that with my suspension. So this is some of the things we want to be looking at today. So you must first of all understand this concept before we move to problems in inequalities. Just a minute. Come on, it's feeding everything. So we are looking at some questions right now. So I want us to start with something very, very easy. Something very, very easy. Okay, let's look at this together. Excuse me, let me clean this. So let's look at this. Let's solve this together. This is linear inequalities because it's still linear, like a linear equation. Okay, so we have 4x minus 5 greater than or equals to 2x plus 11. Let's solve this first. Now, this is like a linear equation. It will be an equation if this is an equality sign, but it's still the same idea. So just see this as an equality sign, but inequalities has its own rules, all right, that you must follow. Now, what do you do here? We collect the like times. The x will be on one side, the numbers, the constants, we move to the other side. Now I'm starting with this is 4x, all right, this is 2x, coming here becomes minus 2x. Then you follow through. The sign that we have is greater than or equals to what we have here, 11. This is minus 5, coming here become plus 5. So solving here, we have 2x greater than or equals to 16. If you add that, then from here you divide both sides by 2. So if I divide both sides by 2, okay, what is x? X is greater than or equals to 8. Now this is the first example. Very easy. Now nothing changes here. Our inequalities will not change. Now now you as a student, you may not be taught this in your school. You have to, if you really want to understand this, check the value. Now the question says, let's check if it is true. Look at our equation. 4x minus 5 greater than or equal to 2x plus 11. Now, and our answer is not just about solving, is you getting the concept, all right, that, oh, look at this, x is greater than or equals to 8. Now, what are those values? Think about those values of x that is more than 8 or up to 8. That is, it is greater or equal to 8. So if it is greater than 8 or equal to 8, that means the value can start from 8. Now, if I say, it means that x can be 8 here. It also means that x can be 9. It also means that x can be what? Can be 10 to infinity. X can be a positive infinity too, because it keeps going. Now, how does this concern us? Now, let's put the value of x into here. Let's come back here and operate. Now let's assume that x is greater than or equal to 8. That means x, if x is, it means that x can be 8 here. So if I put the value of x as 8 here, does it obey these inequalities? Let's see. Now if I put x to be 8 here, that means 4 times 8 is 32. 32 minus 5, that gives me 27. All right, so on this side we have 27, and the greater than, or let's see if it will be greater than or equals to what is here. Now the same 8, put 8 here. Now 2 times 8 is what? 16. 16 plus 11, that is what? 27. Now does this obey our inequalities? Yes, it does, because 27 is greater, or if it's not greater, is equal to 27. So that means this is correct. Now let's try for 9, because x can be greater than 8 or up to 8. Now it's more than 8 now. So let's try for 9. If I decide to put 9 here and 9 here, let's see if it will obey the inequalities. It's not just about solving the solution. So 4 times 9 is 36. 36 minus 5 is 31. Let's see. Then 2 times 9 is 18. 18 plus 11, that should be 29. Is this correct? 31 greater than or equals to 29. So that means this is correct, because 39 is greater than 29. 31 is greater than. If you go on and put the value of 10, 11, 12 to infinity, it obeys that. So that is the first thing I want you to understand. And hold on, there are some times that it does not obey it. That means you need to do something also. It's not just about solving the answer. You must look for how the inequalities will be obeyed. All right, let's look at another question here. Now let's see. Let me show you something else. So let's try here. Let's we have question. Okay, let's see. Minus 2x minus 5 greater than 3. So if you ask to solve for x here, what do we do? Obey the law, collect the like times. Minus 2x is here, greater than, don't change it yet. Now this is 3, this 5 is coming to me 3, is minus 5, coming here becomes plus 5. All right, so what do I have? I have minus 2x greater than what? 8. Right, what do I do? Divide both sides. Although some people will tell you to divide both sides by negative sign, anyhow you do it is correct. Okay, so divide both sides by 2 or minus 2, the way some people should do it. So we divide both sides by 2. This cancel this is 4. Now we have minus x greater than 4. Now in mathematics, when we want to solve this, if minus x is equal to 4, what do we say? We say, so therefore x is 4. Actually the real reason is that whenever you have something like this, you multiply both sides by negative 1. Okay, so let's assume I have minus x equals to 2. The law is that multiply both sides by minus 1. So if I multiply this side by minus 1, the minus will react with this to become positive x. So I have x here. Then the minus 1 times this side becomes minus 2. So why some people will tell you that transfer the minus to the other side, which is a short way, is correct. All right. And also, if I have minus x equals to minus 5, what do I do? Some people will say minus cancel minus is correct. Some people will say divide both sides by minus is correct. But the actual way is still you multiply both sides by minus 1. So if I multiply this side by minus 1, what do I have? I have x. The minus will with the negative to become positive. And also here, I can also multiply this side by minus 1. It gives me positive. So anyhow you go about this, is you are welcome. Is correct. So guys, here, now, whenever the x or the variable that you are looking for is negative, now you want to transfer this sign to this place, it will affect the inequality. Okay, so it's going to change my inequality sign to the opposite. If this guy is greater than or equals to, now it will change it to less than or equal to. If it is greater than only, it's going to change it to less than only. So now we have to say therefore s is now less than minus 4. Now let us try it. It's not about solving the question. Try it and see if it obeys this. Now what are the values that are less than minus 4? Those values are what? I think they are minus 5, minus 6, where minus 7, So where? Negative what? Infinity. We have positive infinity to the right hand side or any, then we have the negative infinity also. But as it is, this value, all of them are less than -4. Now let us pick each of them and impute it into our inequality. Let's see if it obeys this. Now let's assume our s is now minus, because we said that s is less than -4. So what are those values? Now, it's like I said, it's not about you solving it. It's about you understanding what is really happening with these integers. You knowing the relationship between the inequalities used for integers. When s is less than this, when s is greater than that, how do you understand the concept? So that's what we are looking at. Okay, now we said that s is less than -4, so let's use -5 for instance. So if I have -2 into, put -5 there, okay, then -5, is it greater than 3? Let's check. So what is this? 10, right? -2 times -5 is positive 10. Then 10 minus 5 is 5. Is 5 greater than 3? Yes. Let's try -6. If I put -6 here, this is 12 minus 7, 5 is 7 greater than 3? Yes. So if you put any of these values of x to be, the condition is to be less than -4. If you put it here, it obeys this. And like I said, it is not all that obeys that. When we get to that situation, what do we do? So that's what we are going to be looking at. Let's look at other questions. I have some questions here also. I want to believe, please, is there any question? I'm expecting you to ask question online. So you can ask me, you can type it. You don't understand this, I'm going to explain it. I'm looking at you guys. So let's look at another one. Let's try here. So let's assume I have 5 minus 3x greater than or equals to -4. Okay, so how do we solve this? Now, the same way, all right, we can collect the like time. -3x greater than or equals to -4. This one is 5 plus 5, come here become -5. So what do you have? -3x greater than or equals to -9. Now, look at this again. In this place, when the letter is negative, it affects the inequalities to change. The same way, the one you say minus cancel minus, that too will also change this. So now I'm going to have, now you divide both sides of, sorry, by -3 or 3, anyhow you go is correct. So divide both sides by 3 is you understanding the basic, that's all. Then this is 3, so we have minus x greater than or equals to -3. Minus will cancel minus. Now when the minus cancelled, it affects this to change to opposite. So now my s will be less than or equals to 3. Now if you didn't know and you say that s is greater than or equals to 3, and then you put the value of 3, you may get 3 to be, if, okay, let's assume I didn't change this, you didn't know, probably you, now in the option, let's say option A, B, C, D, you may see this as option A, s is greater than, I get it. Then you see this as something like this, then you see C as something like this. You may think this is the answer. This is the correct answer. Now even though you try the first one, let's say if you are not patient enough, if you say s is greater than or equals to 3, and then you, of course 3 is inclusive, you start with 3 and you put 3 here, it may work at the beginning. Now all the ones we have been doing, it must be able to work for all of them, but here it can only work for, I think, 3. Let's try it. So if I put 3 here, now 5, this one is 3 times 3, 9. So that is 5 minus 9 is 4. Okay, is 4 greater than or equals to -4? Yes. Now let's try for 4. Sorry, for 4. Sorry. Excuse me. Okay, 5 minus 9. Sorry, -4. Thank you. So is -4 greater than or equals to -4? Yes. It is greater or equal. It is equal to it. So this one can work. Now let's go for 4. The rest can also be 4. So if I put 4 here, 3 times 4 is 12. 5 minus 12 is -7. Is -7 greater than or equals to -4? No. minus 7 is not greater than 4. No, it's not. If you look at your number line, this is 0, 1, 2, 3. This one is minus 1, minus 2, minus 3. Now, the more I go here, the more I go here, the more big or bigger this number becomes. But the more I go on this side, the more smaller they become. Or sorry, the smaller they become. Okay, the smaller they become. Don't mind my English there. All right. So now that means that minus 2 is less than minus 1, and minus 3 is less than minus 2. Minus 10 is less than minus 9. Minus 10 is less than minus 1. Minus 1 is greater than minus 10. Minus 1 is greater than minus 1 million. You should know that by now. So the farther you go on the negative side, the lesser they become. All right. So that is why minus 7 cannot be. So that means that this guy is wrong for you to say x is greater or equals to 3. Now, what is our right answer now? Our right answer is going to be x is less than or equals to 3. And now we have checked for 3, it worked out. Now, if x is less than 3, that means x can be 2. Let's try 2 here. If I put 2 here, what do we have? 3 times 2 is what? 6. Right? So 5 minus 6. Is that not minus 1? Good. Now, is minus 1 greater than or equals to minus 4? Yes, it is. If you try for 1 also, you get the same answer. It works. So it is not just about you solving, it's about you understanding the concept, the basis of that. Now we are going to move to something complex right now. Let me clean this side. So when you have this type of question, what do? Let's look at it together. Okay, let's look at this together. Let's assume I have x minus 3, then x plus 4 greater than or equals to 2. Let's solve this together. Now, guys, you don't cross multiply here. Do not cross multiply. If you cross multiply, you may be misled that you will not really get the full details of what is happening. So don't cross multiply. So what do? Just bring this guy back, then equate it to 0. Let's go there. So I have x minus 3, x plus 4. I'm going to solve the 2. That will be, if the 2 is coming here, it becomes minus 2 greater than or equals to 0. This one will become 0. Look at it. If I have x plus 3 equals to 5, or let's say x plus y. Now I can bring this 5 here, x plus y, then this 5 can come back and it's plus, come here become minus 5, then what is going to remain here? 0. So that's what I did. I brought this 2 back as minus 2, then equate it to 0. So what do I do here? This is over 1, find the LCM. My LCM is x plus 4. So x plus 4 here gives me 1. 1 times this guy gives me this guy back. Then 1 in this guy is this guy times minus 2. So that I have minus 2 into x plus 4. Then greater than or equals to 0. All right. So that gives me, now remove the brackets, x minus 3 first. Don't say minus 3 minus 2. I don't know, that's wrong. So settle this first. So minus 2 times x, that is minus 2x. Minus 2 times plus 4, that is minus 8. Then divided by x plus 4, greater than or equals to 0. So what do? Here I have x minus 2x as minus x. Then minus 3 minus 8 is minus 11 divided by x plus 4 greater than or equals to 0. Now, guys, what do we do here? Don't cross multiply. It only means that this guy, okay, is greater than this, or this guy is also greater than this. So that means I have minus 11, minus x minus 11 greater than or equals to 0, or let's try this, x plus 4 greater than or equals to what? 0. So what do here? I'm going to solve. So I have minus x now greater than or equals to, this one will move here, that is 0 plus 11, okay, collect the like times, or x greater than or equals to 0 minus 4. Let's go there. So we have minus x greater than or equals to 11 or s greater than or equals to minus 4. Now, nothing will happen here because my variable, the x, the letter, does not have the minus. When it is the number that have the minus, nothing happens. You leave the answer like this. But in this case, my letter, the variable, has the minus. So the minus needs to move here. And there's a law. When it moves, it changes this to the opposite. So now I have, therefore, s is less than or equals to minus 11, or s is greater than or equals to what? Minus 4. Now, guys, let's look at this. Now I can bring the two inequalities together by saying, or I can try them both and put it here. Will it work? Let's see. Now, hold on. If s is okay, let me join these together first. That means I can say that minus 4. Okay, hold on. This actually means that s is, no, not minus 4. I cannot start with minus 4 because minus 11 is, look at it on the number line. This is minus 4, minus 11. Right? So, of course, minus 11 before, if you are coming like this, minus 11 before the minus 4. So that means it's in between this guy. Okay, so the values are in between this guy. Then with minus 11 and minus 4 inclusive, that means I need to shade. No worry, I'm not teaching this yet, okay? But I'm just teaching the problems. Okay, that means that the value of x ranges from minus 11. Look at it. S is less than minus 11. The value of x are less than minus 11. That means it can be minus 12. Sorry, minus 11 is good because it's less than or equals to it. So that means it can be minus 11, then minus 12, minus till it's open. So it will be an open interval. Look at it, minus 11. Can you see now? Minus 11. Then coming here, coming to where? Greater than, or there's a full stop, a bus stop. No. This one, yes, this one is less than. Yeah, this one we have to. Sorry, I'm going to use an open interval. Look, that's why in maths you need to be very careful. I cannot use this type of brackets. I will show you how to use this bracket and this bracket. And sometimes you can use the both. I can use this and this. Sometimes I can use this and this. So sometimes I can use this and this. Sometimes I can use this and this. I will explain all. Okay, now at this junction, this one means it's an open bracket. That is, it can accept all that numbers. That is, it does not really stop here. Look at it. S is less than or equals to minus 11 means that S can be minus 11. It can be also minus 12, can be minus 13 to what? Negative infinity. Then how about this? S is greater than or equals to what? Equals to what? Minus 4. Look at it. That means minus 4 is inclusive. Then it can also be more than minus 4. That means I have minus 3, minus 2, going to where? Positive infinity. So that's why I'm using a close, sorry, an open bracket. So this is the right answer for that. Do we get it? Yeah, I believe you get it. If you don't understand, you can ask question on the message box. I'm going to look at them. All right. Now, if I want to join this, how do I join it together? I'm going to say minus 11 less than or equals to x. The x is less than or equals to 4. Look at it, meaning that, oh, no, I can't write it like this because x is more than 4. No, I can't write it like this. Never. It can't work. So let's leave answer like this. So x can be minus 11. Sorry, this or this. Do I need to check? Let me check. If x is greater than minus 4, can it work? So let me put minus 4 first. If I put minus 4 here, minus 4 minus 3, that is minus 7. Minus 4 plus this is what? 0. Can I have, hold on, can I have minus 4? No, I don't think so. It's going to give me undefined. We can't have minus 4. Minus 4 is not part of the deal, guys. It's not. If I'm writing my answers, okay, minus 4 will not be there because it's going to involve, and it's going to give me an undefined value, which is wrong in mathematics. Okay, hold on. I'm still coming back here. You may not understand. Let me add one more example that will clear your mind now. Let's look at it. Probably the last example, or I don't know. Thank you. I'm seeing people saying it's clear. Okay, hello sir. Good day everyone. Thank you. Thank you. Thank you. Yeah, I can see all your messages. All right, let's look at one more question. So I'm coming back here. Okay. So I posted a question online. That was on Christmas Day. I asked you guys to solve 12 divided by x greater than or equals to 3. Let's look at this together. Then I put options. Now, if you want to solve this, I said you should not cross multiply. What do? Bring the 3 here. So I have 12 divided by x minus 3 is 0. Just like this. Then this over 1. Find the LCM. That's x. X here is 1. 1 times 12 is 12. Then 1 here is x. Sorry, 1 here is x here. X times minus 3. That is minus 3x greater than or equals to 0. Now, what does this mean? It means that x is greater than or equals to 0, or 12 minus 3x greater than or equals to 0. Automatically, x is greater than or equals to 0. Or, let's solve for this, please. So here I have minus 3x greater than or equals to what? Minus 12, isn't it? 0 minus 12. Minus 12. So here, of course, this one will cancel it out. So I have, you divide both sides by 3. It will change the sign, of course, to what? Because I've cancelled. So that is 12 over 3. So here, my s is less than or equals to 4, or greater than or equals to 0. Now, let's look at the options. Option A says this. I'm going to read out the option now. Option A says s is greater than or equals to 4. Option B says 0. 0 is less than x, then less than or equals to 4. That's what I'm going to do here. Then you can tell me your answer here. Then option C, we have x is less than or equals to 4. Then D, we have 0 less than or equals to x, less than or equals to 4. Then E, none of the above. That was the options from the questions that I gave on Christmas Day. That was yesterday. Now, looking at this question, a lot of guys picked A, some of them picked C, many people picked D. Many people picked D actually. They say D is the answer. Okay, let us look at it together. Now that we have said S is greater than 0, or sorry, greater than or equal to 0, that is, S can be 0 too. Now let's impute it here. Guys, if I say my s is 0, what do you see? 12. What is 12 over 0? Undefined. We can't have x to be 0. Now look at the options now. Look at this option now. We can't have x to be 0. Now look at this. Can s, now s can be greater than or equal to 0. That means s can be 0 actually, but it does not obey the inequalities. So it can't be 0. You have to switch to the next one to avoid undefined value. Then, can it be 1? Let's try 1. Can x be 1? Yes, it can. Now, if x is 1, 12 divided by 1 is 12. Is it greater than or equal to 3? Yes, it is. 12 divided by 2. Is it? By 3? Is it? And there's a boundary. It can be greater than or equal to 0, but what? Less than or equal to 4. To 4. Okay? That means I can join them together by saying, look at it. If I use this now, is this now, look at this answer. Of course, s cannot only be greater than 4. Now, if for those guys that will cross multiply here, what do? You say s is greater than, sorry, 3s, right? Greater than equals to 12. Here we divide both sides by what? By 3. What's your x? S will be greater than equals to 4. Option E, correct. It's not correct because you didn't follow the procedure. That's why today's class is very, very important for somebody like you. I mean you. Okay. That's all about that. You have to follow through the same process and then you are good to go. Now we have seen that this is wrong, and of course this one is not complete. When you go through the process, you understand that okay, this is wrong. Then why is this one not correct? If you, that means sorry, 0 less than or equal to x means that 0 is inclusive. Look at it, guys. If I say 5 less than or equal to x, less than or equals to 9. That means you are telling me that the value of x starts from 5 and ends at 9. If I have it to be, let's say, 5 to be less than or equals to x less than 9. This one ends at 8 because it's not up to 9 again, it's less than 9. This one is less than or equals to 9. If you see this value, it means 5, the value of x starts from 5. Look at it. Less than or equals to 5. S is less than, is this side and this side. So this S is less than or equals to 5 and it's also less than or equals to 9. So if I starting from 5, if it's less than or equals to 5, that means I can have 5. Then all the way, there's a boundary from 5 to another number, and that number is 9. What happens to 9? It is less than or equal to 9. So that means 9 is inclusive. But if I say it is just less than 9, 9 is not there again. It just be 8. Now, if I erase this, that means I cannot start from 5. I have to start from 6. Since it's between 5 to 9, and now 5 is not there, and I must move from 5 to 9. Now 5 must not be part of it according to what I have here. Of course, I'm starting from 6, then 6 to what? 6 to 8. If I put a underneath, that means 6 to 9. So you need to understand this concept. So if I have 0 less than or equal to x less than or equal to 4, that means that I'm saying that 0 is part of it. Now if I put 0 here and I try the inequalities, it doesn't work. Okay, so that means 0 will not be part of it. But here I can come here and see, is 0 part of it here? No, that means the value starts from 1. Then 1 to where? To 4. If I put 4 here, 12 divided by 4 is what? 3. Is 3 greater than or equals to 3? Yes. If I use 3, 12 divided by 3 is 4. Is 4 greater than or equals to 3? Yes, it is. Now let's come back here and see if you can apply the same logic to it. Now we have two things. We said that x is less than minus 11. How do we? Now let's try it. For x to be, okay, I think we have tried. Yes, we tried for minus 11. Yes, let's try it now. Minus 11 here, what do we have? Minus 11 minus 3. Is that not minus 14? So here, the denominator is minus 14. Let's try this. Minus 11 plus this. What do you have? Minus 11 plus 4. Is that not minus 7? Okay, if you divide this, I think I have 2. So is 2 greater than or equal to 2? Yes. How about minus 12? Let me try minus 12. Minus 12 minus 3 is minus 15. Then minus 12 plus this. Is that not minus that is minus 8? Cancel. So 15 minus divided by 8, that should be 1.8. This is 1. Remainder 70. 8 in 70 is 8. 1.8. So let's just say 1.8 wherever. So is 1.8 greater than or equals to 2? No. Something is wrong too. Okay? Something is wrong. Very, very wrong. Okay, let's try minus 13 again. Minus 13. This one will be minus 16 minus 13 minus 3. That is minus 16 divided by minus 13 plus, that is minus 9. If you reduce by nothing, 16 divided by 9, what do you have? 16 divided by 9, we have 1 point, remainder 7, 70, 9, 70, 63. I mean, that should be 7 times 1 point. It cannot be greater than or equal to 2. So, guys, this is not correct. For x to be equals to minus 11, so less than or equals to minus 11, may not be correct. So, what do you now do? Can we switch? So, that is one of the situations that we are talking about, that there is need for us to try the opposite. So, if we try the opposite, can it work out? That's what we are looking at. Can it work? Now, let's try x to be greater than or equals to minus 11. That means I've tried for minus 11, it worked. Let me try minus 10. Let's try minus 10. If I put minus 10 here, minus 10 minus 3, what do I have? Minus 13. Good. Minus 13. Let me clean this side. Sorry, we are wasting a lot of time under this. So minus 13 divided by, then I have minus 10 plus this. Is that not minus 6? So this cancels this. This one is 1 point. Sorry, 2. Of course, 2 point something is greater than this. 2 is greater than or equal to this. even though it is 2.1, is greater than or equal to 2. Let's try minus 9. Minus 9 will have been minus 12 here, minus 12 here, minus 9 minus 3 minus 12, minus 9 plus 4, that is minus 5. So if you cancel this, you have 2 points. So it keeps. So that means my s cannot be less than minus 11. It's wrong. So therefore, guys, my s is greater than or equal to minus 11, or let's try for this. That's why I said you need to understand the concept of inequalities. It's not just because if you have solved here, then you will not know how to combine the two together, like relating it like this one here. Okay, so if s is greater than or equal to minus 4, that means let's try for minus 4. Minus 4, minus 3, minus 7, minus 4. It cannot be minus 4 because it gives me undefined. Let's try minus 3. Okay, minus 4 is not part. That means if I'm writing something here, I don't have to involve this dash under. It must not include minus 4. So guys, let me try minus 3. Can minus 3 work? Minus 3, look at it, minus 3, minus 3, is that minus 6? Guys, minus 6 divided by that, minus 3 plus this 1. Okay, is minus 6, am I correct like that? Yeah, is minus 6 greater than or equal to minus 2? No, it can't. So how about we switch this back to less than or equal to minus 4? So if I switch it to x is less than or equal to minus 4, what do I have? Let's try minus 5. Let's try minus 5. Minus 5 minus 3 is minus 8. Minus 5 here is what? Minus 5 plus this, minus 1. This cancel this, right? I have 8. Is a greater than 2? Yes. Let's try minus 6. If you put minus 6 here, what do I have? Minus 6. Here, I have minus 9, minus 2. This cancel, I have 4 point something. It's greater than this, right? Then if you try out that one, it will work out. So that means I cannot have this. So I'm going to change it to less than or equals to minus 4. But minus 4 should not be part of it. So why do I join it together? Guys, look at it. S is greater than or equals to minus 11. More than it. Greater. Where is it going to? And this one is less. S is less than. Okay. Let me just stop here. Let me stop here so that I will not confuse some people. So guys, this is the correct answer and not the other way around. Because if you try all this, it does not obey what we have. Okay, and if you are sure of yourself, you can put this as this. You can join them together on the group, and I'll be waiting for you. So let me see the time. This is 48 minutes already. Okay, so guys, I think we should I do one more example? Let me ask you. Can you just say yes or no? Let me see. Maybe on quadratic linear inequalities, quadratic, the one that has squared. So how do I go about it? Can we just do one? I'm waiting. I think we need to change this thing. Can you guys hear me? Can you say something? I'm waiting. No, this one has been long. Really? Okay. Okay. I can. So let's look at one more question. Probably, let me still leave this. So the solution to this is this. Correct answer. So you need to be very smart to dictate that and that one also. Okay, so let's look at a question under quadratic inequalities. I think I have a question here. Okay, quickly before then, there's a question here that you may like. Let's say minus 12 less than 7x minus 5 less than or equals to 9. So how do you approach this type of inequalities? So what you should do is, now if you look at this, how do you treat this? We have two inequalities. So at the end of the day, you are going to get, sorry, yes, we have two. So that means you have to solve them individually. Now you are going to look at this can form one. This one can form one of the inequalities, and this guy also can form one. So that means I can have minus 12 less than 7x minus 5, or I can have 7x minus 5 less than or equals to 9. So what do I have here? I can solve it individually by saying minus 12, this one, collect the like times, this one is coming here. So be plus 5, then less than 7x, or 7x less than or equals to 9 plus 5. So what do I have, guys? I have, this one should be minus 7 less than 7x, or 7x less than or equals to 14. So divide both sides by 7, by 7. So this one is minus 1 less than x, or x less than or equals to 2. To divide this, we have 2. But that is not how to, now you know that minus 1 is here and x is, so if you want to switch the value of x to be minus this, that means the sign is to change to this. Or but this one is well arranged, it's okay like that. Okay, so s can be greater than minus 1, or s can be less than what, or equals to 2. So that is the solution to that. Then look at it. If s is greater than or equals to minus 1, can it work here? It should. Look at it. Can it work? What are the values that are greater than minus 1? Minus 1 is one part. That means I have minus 2. Put minus 2 here. Minus 2. 7 times minus 2 is minus 14, minus 5, minus 19. So it's minus 12 less than sorry, let me confirm properly. No. I think there is a wait, hold on. Excuse me. I think I can do it better here. Let's join this together. So I can say that minus 1 is less than x, or is less than 2. So we can use this guy as telling you that the value of x ranges from, now minus 1 is not inclusive, right? Then is less than minus 1, then less than or equals to 2. Okay, let's try this. Let's try 1 first. Let's try 1. Can 1 work? 7 times 1 is 1. 1 minus 5 is sorry. 7 times 1 is 7. 7 minus 5 is 2. So is minus 12 less than 2? Yes, it is. Let's try for 2. If I put 2 here, 7 times 2 is 14 minus 5 is 9. Is minus 12 less than 9? Yes, it is. Now, it's telling you that s cannot be minus 1, but s can be 0. If s cannot be minus 1, then it can be 0, because it's from minus 1 to 2. The boundary, okay, is from minus 1 up the way to 2. But minus, because of this, it does not involve this. It does not have equal to. So minus 1 is not there. All right. So that means s can be 0. Let's put 0 here. If I put 0 here, the whole of this way will be minus 5. So is minus 12 less than minus 5? Yes, it is. So that is very, very correct. Okay. So you must learn to check, cross check what you have solved, check the inequalities that you have, and then we are good to go. Let me just mark this list. This center. Yeah. Okay. So let's pick one question on any question, guys. Let me see. Hope there's no question. Okay, we can hear you. Good. I can see you guys. Let's see. Mm, I'll be ending the class very soon. This is this although we didn't start exactly by 4, I think. So I think in the next 5 or 10 minutes we can end the class. So let me clean this side. So if you have not written it, you can always go back to the channel. All right. If you have not subscribed to my channel, please do that. Do that right now. Just click on the subscription button and do that right away. Thank you. So let's look at the last question. It's going to be on a quadratic. So let's look at this. If I have x squared minus x minus 12 less than 0, now how do you solve this? Now your normal way of solving quadratic equation, do it here. So you come here, right? So if you multiply this, you have minus 12x squared. The value multiplied together that gives you minus 12. That should be um we have 6 times 2, we have 4 times 3. So the one that will give me this is minus x. That should be minus 4x plus 3x, then minus 12. This one can replace this guy. Okay, so you can group it, factorize. X is common, x minus 4 plus 3 into x minus 4, or of course less than 0. So we combine them together. This one are the same, pick one of them, then less than 0. So each of them, in normal equation, if sorry, the equality sign, you said each of them is equal to 0 the same way. So that means each of them, x plus 3 is less than 0, or x minus 4 less than what? 0. So if x plus 3 is less than 0, what do I have? That means s to be less than minus 3. This one comes here. Or s will be what? Less than 4. So how do I join this? There's a boundary of x from ranges from minus 3. Look at the minus 3, less than x, less than 4. So what are the values of x? X ranges from where? Does minus 3 is minus 3 part? No, it's less than it. So that means I can come from minus hmm, minus what? Okay, this one minus 3 is one part, and I'm coming from minus 3 all the way to 4. All right, so that means there'll be minus 2 there. This set now, I have minus 1, 0, 1, 2, 3. Is 4 parts? No, there's nothing like this. It does not involve 4. So the inequalities is stop at 3. That means that if you put 4 here, you are wrong. Now let's try minus 2. Minus 2 square is 4. 4, this one is minus 2, minus that is plus 2, right? And then minus 12. What do you have now? 6 minus 12 is minus 6. Is minus 6 less than 0? Yes. Minus 6 is not to 0. Let's try for 3. 3. If I put 3 here, 3 square is 9, right? 9 minus 3, 6. 6 minus 12 minus 6 is less than 0. Correct. Now let's put 4. 4 square, 16 minus 4, 12. 12 minus 12, 0. Is 0 less than 0? No, it can't work out. So all these things are real, guys. Understanding the basis of inequalities, and that gives you the joy in it. So guys, I think on this note, we have to call it a day here. We have to stop the class, and I really want to appreciate those of you that joined the class. Thank you very much, and people that have subscribed to this channel. So we are going to see more of this. More of this is coming soon. Like I said, all those topics. If you can type the topics you want me to treat, put it there. I'm going to handle all of them. Any topic in mathematics, further mathematics you want me to address, put it there. I'm going to be doing it gradually. Okay, so for now we are back again. TeeMath is back. TeeMath Academy is back, and I will see you guys at the top. Thank you very much. Enjoy yourself. Shalom. So let me end the class. I think I can't hear. Salam, are you still there? Oh, we have people. Okay, I think I have Bola J Harris. Okay, okay. This is yeah, interesting. I think I have Sumishi Daudu. Okay, Salam. Salam. Thank you very much. Thank you guys for coming. Thank you. Thank you. Thank you. Thank you. So I think I need to end the class now. It's already 1 hour. Thank you very much. Bye. Yeah.